one, that I want to make sure everyone knows that we are recording this, and so if you or your colleagues need to see this at another time, you're welcome to then access it on our website again. So we'll get that recording up very soon after we complete the session today. The other things to keep in mind on your dashboard there are we will keep you muted throughout the episode. So if you do have a question or something that's unclear or you're having tech problems, the best thing to do is to chat to me directly. Again, my first name's Patsy, and you can find me in the chat box there towards the end. And there's an arrow at the very bottom of the screen that can help you find just to chat to me, and then I can help you through those tech problems. If you end up chatting to the whole group, that's okay too. I'll help you out. So other things of note here, there's some controls as far as, again, minimizing and maximizing audio, etc. So we will not be using the webcam, so there's nothing you need to do there. You can look at the attendee list. It looks like we have about 35 people with us today. So it's a plus sign. Until you hit the plus, it becomes a minus sign next to the word attendees, and you can see the entire list of who's present with us today. The big important thing probably is going to be your chat box, though, if you have any troubles. I think we're ready to get going. I'm going to turn it over to Andy and Abby.
Welcome, everybody. My name's Andy. I am a teacher at the Robbinsdale Area Adult Academic Program, and I'll be one of your facilitators today.
I'm Abby. I work for Hennepin County through Adult Options in Education, and I'll be the other presenter.
And I'm Patsy, I mentioned before, and so I'm at the bottom of your screen here, and I'm just here for technical backup.
Okay, and just like Patsy said, everybody's been muted. If you have a question, you can chat to Patsy, and then we're going to go through things pretty quickly, but we will have some time at the end to chat with us possibly, and we will have that week after the webinar for you to send us any questions you might have. Please do not hesitate to put in some questions on the chat box. Okay, so some of you have probably already been through the eQuip Math PD series. This is a web-based professional development that we've designed through M&I, and it's to help teachers get ready for the GED 2014 and the assessment targets that are going to be connecting into that for the algebraic reasoning.
All right, so if you've had a chance to look at the GED assessment guide, which is available for free download on the Testing Services website, you've seen the assessment targets, and there are 5 that we've identified that deal with quadratics. So this first one is dealing with comparing, looking at graphs and identifying, being able to sketch graphs, identifying the features of graphs. You dealt with that a little bit in the pre-work. And we'll deal with it just a little bit today. The second one deals with, plugging in values for x in quadratic functions. And again, you get to deal with that a little bit in the pre-work. We're not going to do very much with that today. We're going to deal a lot with the third one, being able to solve in one variable. We're going to touch on the quadratic formula today. We're going to deal with factoring. And we're going to do a little bit on inspection. We're not going to deal with completing in the square today, but again, in the post work that you'll get in an email after the webinar, there'll be information about that there. This fourth one, compare properties of 2 functions, each represented a different way. We'll do a little bit with that today. And write one variable quadratic equations to represent context. There were quite a few of you that had questions about that. There will be material in the post work, and we'll do one example of that today. All right, so our objectives for today, taken from some of those assessment targets, are that you're able to recognize a quadratic equation in standard form. And dun, 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 we're going to do that right now. Here it is, ax squared plus bx plus c, where a, b, and c stand for numbers. And what's important is that there's an x squared in there to make it a quadratic. We're going to work with multiplying binomials, and we're going to visually represent that task using Algebra Tiles. And again, in the pre-work, you started to do a little bit of that. We're going to solve quadratic equations in one variable using factoring, and we're going to visually represent that task again with those Algebra Tiles. And we're going to work with the quadratic formula.
Okay, so when we ran into this, and we did a little bit of training with Rebecca and Amy at the pre-conference at Summer Institute, there's a lot of questions about quadratic, and what does it mean, and what's this new thing we got to deal with? And I want you to realize it's really not all that much different than the stuff you've already done. There's a few little tweaks, but if we can make the connection to your prior knowledge and help you to make the connection for your students to prior knowledge, it's not that bad. So in quadratic, all quadratic means it has 4 of something. So a quad motorcycle has 4 wheels. A quadrilateral has 4 sides. Our nice dog, which is a quadruped, meaning it has 4 legs or 4 feet. And the quadrants that many of you have used when you talk about graphing in the XY coordinate grid. So anytime we're talking anything about quad, it's got 4. So how does that affect us here? Well, a quadratic function is something that describes a variable with a second power. For example, the area of a 4-sided object. So if we have a square, we know that that thing's just a rectangle where the base and the height, or the length and the width, happen to be the same. So the area in a square is just b times h, which h then is the same as b because it's square. Then the area is just b squared. Or if you get into a rectangle, we can take a whole big rectangle and break it into smaller chunks for area, and we've been doing that for the 2002 base test. But we're talking about, for example here, 4 times 2 being 8 square units. So everything in here has something to deal with a square. So a quadratic function has the form of f of x equals ax squared plus bx plus c, just like Abby was talking about, but there's that functional notation with f of x. We're going to be very interested in what happens when that thing equals 0, when ax squared plus bx plus c equals 0. That's going to be an important one for us. So how do we end up with these quadratics, with these things in that form ax squared plus bx plus c? Well, a lot of times they come from binomials. Binomial just meaning, as we think about a biplane or a bicycle, bifocals, and of course, coming up in Sochi here in a few months, the biathlon, just something where 2 things have been put together. So bi meaning 2, and nomial just being a name or a term. So when we talk about algebra, when we first start talking about binomials, a lot of people recognize the 3x plus 2, the x plus 7, as being binomials. There's 2 terms. But 47, just a regular old everyday number, that is a binomial as well. And if you can make that connection for your students that they already know binomials, because they already deal with 2-digit numbers, then it's not as scary as what it thinks when you get this new term binomial. So we're going to go through just a little bit of mathematical connections on these to kind of remind us of some things we already know and make the connections to the new stuff. So if we're adding 2 binomials, like that 47 we just had, and 32, of course you all know that that comes out to be 79. But really, what are we doing? That's really 40 plus 7 and 30 plus 2 being added together, and of course you add the 7 and the 2, and you add the 40 and 30, making 70, and then you put it back together and make 79. But we can really look at that as 2 separate pieces, and I can only add the 40 to the 30 because they're both 10s. Well, if we look at this in the same way, but just with x's instead of multiples of 10, then the 40 plus 7 just becomes 4x plus 7, and the 30 plus 2 becomes 3x plus 2. We can add those. And we do the exact same thing. 7 plus 2 is 9. 4x plus 3x is 7x. Most of our students are fairly, at least most of my students, are fairly comfortable with that. It's when we get into subtracting, they start to get a little bit shakier, and then when we get into multiplying and dividing, they get a lot shakier. But when we can make the connections, again, they make a little bit more sense. So if we're taking those same 2 numbers and subtracting them, really what are we doing? Well, that's 40 and 7, and we're taking away 30 and 2, but we can go ahead and say that we're taking away 30 and we're taking away 2, and of course you subtract the 7 and the 2 and the 40 and the 30 just without even worrying about separating them out. But if we see them separated, then it looks an awful lot like our binomials that we're subtracting. A 4x minus a 3x gives us x, and a 7 take away a 2 gives us 5. Well, there's our x plus 5, the same way we had 10 plus 5 over here. So the only difference is we have x's instead of 10s. So if we can add or subtract these, we ought to be able to multiply or divide them. So we took our 47 plus 32 and we separated it out so we can see the 40 plus 7 and the 30 plus 2 that we're going to do. And we'll look at this as how we multiply them, because this side over here on the left, that 47 plus 32, students are not going to have any problem with. They're very comfortable with that algorithm. When they look at this one and see they're the same, then it's okay. So if we're multiplying those, of course, we do 7 times 2 is the 14. And we carry that 1 up there because it's a 10. You can carry it into the tens position. And then you do the 2 times the 4 is 8 plus that 1 is the 9. The 3 times 7 is, of course, 21. But all of our students know you shift that over one spot so that the 1 lines up underneath the 9. Most of them don't know why you do that. They just know we do it. And then, of course, the 3 times the 4 plus the 2 gives us the 14. And then when we're all done with those, we go ahead and add them all together to get the 1504. So that's just the regular multiplication algorithm. But if we look at it as a binomial, we can see the same thing. Here's that 7 times 2 to give us 14. And then the 2 times 4 is not really 2 times 4, it's 2 times 40, which of course gives us the 80. And if we put those two together, the 80 and the 14, we get that 94 that they're already comfortable with. Once you've multiplied 2 times everything, we, of course, turn around and start multiplying the 3 times everything. And they know they shift that 21 over, but they usually don't make the connection that it's not really 21, it's 210, because that 3 is really 30. And then, of course, the 30 times the 40 gives us 1200. And if we add all those together, I can't add the 1200 to anything because there are no other hundreds. I can't add the 14 to anything because there are no other ones. But the 80, the 10s here, the 80 and the 210 to be 290, those I can go ahead and add. Okay, so it's adding like terms. We're adding the same things because they're both 10s. And of course, we add all that back up together. We get the same 1504. So many of you remember when you've done this prior, or our students, when I brought this up and started to talk to them, they say, well, how do you multiply these things? And of course they say, it's FOIL! You got to multiply with FOIL. Well, what does FOIL really mean? We're just multiplying 2 binomials, and those we have the 47 and 32, that we ended up with the 3x plus 2 and the 4x plus 7, what they would look like if it wasn't 10s but x's. And they all know, well, F, that stands for first. So I take the first ones and multiply them together. Most students, when they see this, are not really comfortable with going ahead and multiplying that 40 times 30 first, but they're quite comfortable with doing this if they've heard the FOIL acronym before. And notice we get the same things. We get the 1200, we get the 12x squared. If we multiply the O's, those are the outsides, the 3x times the 7. And of course, 7 times 3 is 21, but there's that x still hanging around there. That was our 210 that we had before. When we do the insides, our 40 times 2, that's our 80 that we had from before. And the 2 times 4x is 8x. And our last there for the L is the 7 times 2 is 14. And then when we're all done, just like we did with the numbers, we can go ahead and add like terms. So we end up with the 1200 plus the 290 plus 14, or in terms of x's, the 12x squared, the 29x, and the 14. I can't carry that 1 up into the x's because it's not 10s anymore, they're x's. But I can combine the like terms. Okay? So when we show that, a lot of my students kind of go, okay, I kind of get it. But the other thing we can do is show them something much more graphically, and you can actually get these. Abby sent you some links of how you can print these out, and this is a fantastic manipulative you can use for multiplying or factoring, and it's Algebra Tiles. So we're going to graph out something that looks like our binomials that we're going to do here. And we're going to have here a 2x, which we're going to represent an x as a long length. So here we've got two long rectangular yellow blocks. And we're going to put three just little blocks out on the end because each little square represents a 1. If I look on the other side over here, I'm going to multiply x, and we're going to actually throw a little wrinkle into it. We're not going to do just +1, we're going to do -1. So in our algebra tiles, anything that is in positives here is going to be in yellow, and anything that's negatives is going to be in red. So what if we went ahead and multiplied these? Well, an x wide times an x long would give us an x squared. But notice since we have two of these x longs, we have two x squareds here, two big squares. When we multiply the outsides, the 2x times the -1, a positive number times a negative number gives us a negative, we get two of these long x value negatives, so -2x. When we multiply the insides, the 3 times the x, we get our 3x, three positive long rectangles. And when we multiply 3 times the -1, our lasts, we get 3, but of course since it's a positive times a negative, that comes out being a negative. So the big important point in algebra tiles is when we're done, what's in the inside here should be a nice clean rectangle. And in this case it is. Anything that has the same shape, these rectangles here on the right and the rectangles down here on the bottom, can be combined, but since it's negative for this -2x, a 3x plus a -2x is simply 1x. So if we looked at this graphically, we see 2x squareds, we see one more rectangle in yellow than we had in red, and we see three little red squares to give us the -3. And that's a way that we can multiply visually to help our students that are more concrete learners. Okay, and we're going to shift here for just a second. And Abby's going to become your presenter.
All right. So I'm going to tell you a story about my garden because we're going to look at factoring quadratics within a context.
Slideshow.
All right.
There you go.
So my garden is, I know that the area is 35 square feet, and that includes the part with the flowers, and it also includes this little edge of bricks on both sides, kind of a little sidewalk there. So I know that the part that has the flowers in it is 3 feet going this way and 5 feet going that way. And I know that I need some more bricks, so I'm going to go to the store and buy some more bricks. And when I get there, I realize that I did not measure the bricks. I don't know how long the bricks are. So normal people would jump in their car and go back and measure them, but we're math teachers, so we're going to figure it out using algebra. So I know that area equals length times width, and I know that I can call the length of the bricks x because that's an unknown amount. And so I'm going to think about area being length times width. And looking along this way, this is x plus 5. Looking along this way, this is x plus 3. So if I follow the steps that Andy's been modeling and I multiply these binomials, I will have a quadratic equation that will represent the area of my whole garden, where x is the length that I want to find for these bricks. I want to make a quick note. Because of some of the constraints of the technology we're using, you're going to see x squared written two ways today. The way on the right is probably the way we're most comfortable with. This x little caret 2 is going to mean the same thing. So regardless of which way you see it, it means x squared. So what I'd like you to do is I'm going to have you take a moment, and I'm going to have you actually go ahead and multiply x plus 5, our length, times x plus 3, our width. And then I'm going to pop up a poll so you can tell me which expression represents that area. So again, x plus 5 times x plus 3, And if you look at the fourth choice there should be a little 2. That little caret is x squared. So it's on it's x squared plus 8x plus 15 on that one. The rest of them are written correctly. Oh, look at you guys. All right, almost there. A few more people. All right, I'm going to go ahead and close the poll. Most of you have put in your results, and I will share our work. So most of us found x squared plus 8x plus 15 as the product of those two binomials. So let's have a look at that. I bet a lot of you did it using the FOIL that Andy was modeling. I'm going to sort of work backwards, starting with last. If you look at the garden, the area of the garden is 3 feet by 5 feet, so that would give us the 15. The area of this chunk of sidewalk is 3 times x, so that's my 3x. The area of the sidewalk over here on the bottom is x times 5, so there's my 5x. And the only chunk I haven't dealt with is that last little chunk of sidewalk, which is x by x, so that's going to give me x squared. If you combine like terms there, you'll end up for the whole garden with x squared plus 8x plus 15. So that is the quadratic equation that represents the area of my garden. And if you remember from the beginning of my story, I know that the whole garden is 35 square feet. I know that I'm going to want to find x. That's what I need to figure out how long these bricks are so I can buy them. And I know that's going to be easier to do if I have the whole thing set equal to 0. So I'm going to subtract 35 from both sides, which will give me 0 equals x squared plus 8x minus 20. All right. So now I want to factor because I want to figure out what x equals so I can know how long those bricks are. And I'm going to model that first using the algebraic tiles. I hope that you had a chance to do some of that pre-work and get familiar with them. But if not, I highly recommend going back to those tools. You might remember on the tiles that you made, they were white on one side and red on the other. I'm going to use yellow so it stands out against my background. So my yellow is positive and my red is negative. That big square tile represents the x squared. And then the next chunk that I'm going to do is I'm going to deal with negative 20. So I want to use those unit tiles, and because it's negative, I'll be dealing with those red tiles. Let's see. I can lay them out. I want to lay out the tiles so that the corner, I'm going to lay them out in an array, in a rectangular array, where the corner of the unit tiles touches the x squared. I'm not going to lay them out side by side next to the x squared because I want to leave room for my x's. So I'm going to consider the ways that I could lay out those. So take a moment and go ahead into the chat box and chat the factors of negative 20. Go on. Yes. Great. If you're not sure how to chat, it's down in the lower right-hand corner in that little window. And if that window's disappeared, there's a little red arrow you can click. Super. Nicely done. All right. So we have the factors of negative 20, and you guys are doing a great job. Yes, Kelly has almost all of them. So I'm going to use, for this example, I'm going to do the negative 5 and 4. So I'm going to lay out my negative 20 unit tiles in an array of 4 by 5. And then I'm going to need to put in my x's. And as Andy mentioned, when you use algebra tiles to represent a quadratic equation, you're going to want to build out a full rectangle using them. So I'm going to want to slot in x's that make sense in the equation and that fill out the rest of my rectangle here. So I'm going to put in 5 negatives for my negative 5, and I'm going to put in 4 positives for my positive 4. So I've got x squared, I've got negative 5x, positive 4x, and I've got my negative 20. Oh, shoot. When I combine like terms, I'm going to end up with negative x, because these 4 positive x's will cancel out 4 of the negative ones. And if I can just think aloud as a teacher for a moment, we want to model coming up with the wrong answer so we can talk to our students about what to do when they get to this point, and also kind of modeling the grit of sticking to it and trying it again and figuring it out. So let's look at that again. What I forgot to do was think of which of those factors are going to add to 8. So when we're factoring, we're going to talk to our students about looking at what are the factors of negative 20, what are the factors of the last term, but also which of those factors will add up, will combine to give us the middle term. So let's try that again. So I've got my x squared, and I'm going to think about the factors of negative 20, and you've already hit those. But this time I'm going to think, well, which of those will add up to give me positive 8? So which of those can I combine to get positive 8? And I'm going to go with a negative 2 and positive 10. So I'm going to lay out an array of 20 units in a 2 by 10 array. And I'm going to go ahead and put in my x's to build out my rectangle. So I'm going to put in negative 2 and positive 10, so positive 10x and negative 2x. If I'm going to combine like terms, I've got 2 negative x's and 10 positives, so that will give me my positive 8x. So this is the set of algebra tiles that will represent x squared plus 8x minus 20. Woo! All right. Now that I've done that, I'm ready to factor using the algebra tiles. And you may have already noticed that you've got these 2 black strips on the screen. You can do this by, you can make this matte by just photocopying those 2 lines on a piece of paper. You can draw them with a pencil. I've seen teachers put electrical tape on the desks, and it gives us a mat for multiplication. You can think of it like when you have students use it for times tables. If you have 1 factor on the top and 1 factor on the side, 3 times 5 would give me 15. But I can also use it to reverse to find the factors. Again, I like to start with x squared. So what are the factors of x squared? I'm going to have x and x. Then I can look at my factor x, and I can look at one of the chunks that's in its row. So I'm looking at the negative 2x, and I'm thinking, what times this x up here will give me negative 2x? And hopefully you come up with negative 2. So as I go, I'm putting in the algebra tiles to represent my factors. I can look at that negative 2, and I can say negative 2 times what would give me this negative 20 over here. Because when I come down from this part and across from the negative 2, negative 2 times what would give me negative 20, and hopefully we come up with positive 10. So now I have the 2 binomials that are the factors of the quadratic that we've been working with. I've got x plus 10, and I've got negative 2 plus x. And as you know, we can switch them, and it's still the same binomial. So I'm going to, for ease, write it as x minus 2. All right, we can do the same thing algebraically. I know that the factors are going to be binomials, so I'll get my parentheses ready to receive them. I start the same way I did with my algebra tiles. X squared, the factors are going to be x and x. I'm going to think, what are the factors of negative 20? We've already generated them. I'm going to choose the factors that will combine to give me positive 8. And I'll have the same binomials that we came up with using the algebra tiles. I want this, I've set this equation is equal to 0. So if I end up with an x minus 2 that's equal to 0, that'll multiply times whatever ends up over here, and the whole thing will be equal to 0. Or if I end up with an x plus 10 that equals 0, that'll multiply with whatever ends up on the left side, and I'll still get 0. So either way, one of these needs to equal 0. So I can solve for x for each of these, and I end up with x equals 2 and x equals negative 10 as my possible values for x. Let's take a quick moment. I know for some of you this will be a frustrating short chunk, so if you have questions after this slide, please discuss with us in the Moodle. But I just want to point out that when I graph x squared plus 8x minus 20, x equals 2 and x equals negative 10 are the points where the graph crosses the x-axis, so where y equals 0. So when you're solving for x, and we're talking about inspecting the graph, you can solve for x by inspecting where the graph crosses the x-axis. But let's go back to the garden. So we talked about how the garden was 35 square feet, and we're trying to find the length of these bricks, which is why we started doing this work in the first place. And we have two possible answers that are correct for the graph and that are correct for the equation. We have x equals negative 10 and x equals 2. But when I think about it in terms of my bricks, I know that the store is not going to sell any bricks that are negative 10 feet long because that doesn't exist, right? So I know then that my bricks are, the correct answer for the context of my problem is x equals 2, or the bricks are 2 feet long. And if I wanted to, I can plug that back into the equation and check it that way as well. All right. So that is the end of the garden problem. I want to look at a different problem that's laid out in algebra tiles and kind of just check for understanding. So take a moment just on a piece of scratch paper and look at these tiles and see if you can write down the quadratic expression that these represent. So we've got some x squared, those are the big ones. Remember, the yellow is positive, the red is negative. We've got some x's, and we've got some units. And hopefully you came up with 2x squared plus 3x minus 2x minus 3. And we're going to try factoring that using the tiles. I'm going to combine like terms first. So I'm going to factor my 2x squared first. So I've got 2 x's, and I've got times x would give me my 2x squared. I'm going to take this x, and I see that whatever is going to be multiplied on the top factor is going to give me 3x, and it's still positive. So I know I'm going to have 3 positive tiles up here. So now I want to figure out what's going to go in this factor on the left. And I would like you to take a moment and think about what tile you would place there and whether it would be yellow for positive or red for negative. And I'll post another little quiz for you to answer. Very nice. Got about half the folks responding. All right, a little bit of controversy over whether it should be a yellow positive square or a red negative square. Maybe worthwhile to consider whether we know 3 is going to be positive, and 3 times whatever ends up over here is going to give us negative 3. So think about positive times what would give us a negative. All right. So for most of you had it, is the small red square, because it's going to be -1, because -1 times +3 would give us -3, and -1 times 2x would give us this -2x, which will then combine to leave us with only 1x in our final answer. All right. So there are factors, 2x plus 3 and x minus 1. All right, I'm going to pass things back to Andy.
Okay, hi, sorry about that. I got to remember to unmute myself. Let's try this again. Okay, so everybody hear me now, I hope. The quadratic equation and formula you will get. Oh, there we go. Thank you, Nancy. The formula sheet has these following equations. The standard form of a quadratic equation, the one we just did, ax squared plus bx plus c. Equaling y, or we could also have here f of x. But there's this new one down there, the quadratic formula. Quadratic formula is used when y equals 0, just like Abby was doing when we solved and subtracted the 35 to both sides so that the equation equaled 0. And so therefore, if 0 is equal to ax squared plus bx plus c, then x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that's a big chunk of stuff. So what does all that mean? So if we had an example, let's say that 5x squared minus 3x minus 4 equals 0, we know that is in the standard form of ax squared plus bx plus c equals 0. So all we need to do is figure out, okay, that means that the quadratic equation works. I need to know what a, b, and c are. Well, a is the 5, b is the -3. Remember that negative has to come with it because it's supposed to be plus bx, and the plus c makes c -4. So how can we plug this into the quadratic formula and come out with a solution? So there's our same equation that we just had, the 5x squared minus 3x minus 4 equaling 0. Again, it's in standard form. So first thing we want to do is plug the a's in. Well, that 5 just splits out and replaces the a's in the equation. The -3 goes in every place there was a b, and that -4 goes out to that one spot out there at the end where there's a -c. So now we've got this big thing, the opposite or the negative of -3, plus or minus. Okay, there is two solutions here. We're going to talk about that a little bit more in a second. Square root of -3 squared minus 4 times 5 times -4 all over 2 times. Oh, that's still big and ugly. That hasn't really made anything any easier for us. But what if we can go through and start to simplify this? We know, and our students hopefully know, that we're going to be using the PEMDAS, or please excuse my ignorance, Sally, the order of operations, in order to simplify this expression that is equal to x. So first thing we're going to do is look, say, are there any parentheses? And yeah, there's the parentheses here on the -3, and that's nice, and the parentheses around here on the 5. But really, there's nothing to do there because what's inside the parentheses is already as simple as it's going to get. But remember that everything here inside this square root symbol acts as if it's in parentheses. So this is absolutely the first thing we're going to do. And within there, after we start into the parentheses, we're going to look for any squareds or any exponents, and we do have one. Okay, there's our -3 squared. And if we go ahead and square that, of course, a negative times a negative is a positive, so that becomes +9. And now that we've simplified that, we can look for any of our multiplications. Well, we've got the negative of -3. That is a multiplication. We've talked to our students about what's in front of the parentheses. If there's nothing written there, it's the same as 1. This is -1 times. And -4, or minus, times 5 times -4, and the 2 times 5, those are all our multiplications. If we multiply all those, we get the 3, the +80, and the +10 down the bottom. And then we have an addition to deal with in there. And the 9 plus the 80 gives us, of course, 89. This is the solution. This is it. We're done. So x is equal to 3 plus or minus the square root of 89 divided by 10. Okay, that still doesn't look easy to me. There's something still kind of going on there. We still got that square root involved. We got that plus or minus involved. So it's possible they may ask us, what is the solution? And here it is. But what if they want us to get something that's kind of related to this, and they want an approximation of things rather than, okay, hang on a second, rather than the, there, now we got it. Rather than this exact, and that's if we can go ahead and throw in the calculator. So if we see this, here's our calculator, and this is our quadratic formula. So we can pull in the x equals 3 plus or minus the square root of 89 divided by 10. And that plus or minus means that we have two possible solutions here. Okay? We can do 3 plus the square root of 89 divided by 10. Now, if we're going to do this on the calculator, we do have to do these two separate of each other. So on our TI-30XS calculator, and this is the exact same one your students will use on the test, they can plug into the calculator exactly what they see here. I see a big fraction. So I'm going to hit the fraction key that's right here, the third row down, second column over, and we see the fraction. We go ahead and start entering into the numerator because that's already up there blinking in our numerator. So we have 3 plus, and now we need that square root. So square root on our calculator doesn't really show up on any of the keys, but it's that yellow right above the x squared on our 5th key down, 6th key if we don't count the second. But in order to get that square root, we need to hit the second first, the second prior to hitting the key. So we hit second and then square root, and our square root symbol shows up. We can put in our 89, but now we need to get down to that denominator. And remember, to move down to the denominator in our calculator, we hit the down arrow. And that's going to put us down here blinking in our denominator now, and we put in our 10. If we hit enter, well, all it did was switch that 3 and that square root 89 in different order, but it's really the same stuff. But what we might need to do is come up with an approximation value of this, and in order to switch from the exact value that the calculator will show you and the approximation, we hit the toggle key that's right above the enter, and if we toggle that, it tells us it is 1.243389, or approximately, oh, sorry, I got these in the wrong order, approximately 1.24. Okay, so what if we did the minus? The minus value here, we could do the exact same thing, clear all that off. We see the fraction, so we do a fraction. We're going to do our 3, but now instead of our plus, we're going to do our minus side. We're going to split that plus or minus into two pieces. And if we hit our second square root 89 down to get into our denominator and 10. Again, hitting enter, we're going to get the exact same thing, except for now it's that minus square root of 89. But if we hit the toggle, there's our approximate negative 0.6433, or about negative 0.64. So it's possible the GED test is going to ask you for an exact value, at which point you're going to want to do it with the square roots. But it's even more likely that they'll ask you for an approximation, and that's where we'll have to use the calculator in order to do that.
Andy. I think particularly when students are going to be doing things in context, the approximation is going to be important.
Very much so. And within that, if we have time at the end of the webinar, we'll show how to use the calculator in order to plug this in right from the beginning before we've done any simplification. But we wanted to see how to simplify it and then how to plug it into the calculator. Okay, so now we'll go back and let Abby wrap us up.
All right, so you can see this is just a little taste of dealing with the quadratics, and hopefully this whet your appetite for some more. If you look at the very bottom of this slide where it says http online.themlc.org, you can meet us there for the whole next week to talk about questions about quadratics and ideas and resources that you have that would be good to help other teachers with this area of instruction. We've already posted some materials there that you'll be able to access right away, so please take the time to check in there a couple of times this week. When you close out of this webinar, you're going to have an evaluation pop up, and you can either do that right away after the webinar, which we would really appreciate, or you can do it via email. That you'll get an email post-webinar that you can respond to the evaluation. But either way, if you could do that, that would be very helpful for us. And then in that email, there'll be links to other materials. There's some really great, very detailed lesson plans. There's some videos about teaching aspects of quadratics and other resources that will be coming your way. There is one more equip coming up this month, and I'm hearing great things about it. It'll be about finding surface area and its related dimensions, and it's on December 17th from 3 to 4. So registration will be open right after this, and I highly recommend registering and checking that out.
That's also going to be something that's new to the new test, and there are some specific parts of your formula sheet that episode is going to be really helpful in helping you to understand and helping you to describe to your students.
And then a copy of this webinar, a video copy, and then the related resources will be available on the Atlas website, which is atlasabe.org. If folks have, so that is the end of our webinar. Thank you so much for spending this hour with us. And if you have questions or something you want to bring up, if you go over to the control panel on the right, there's a place where you could raise your hand, and then we will unmute you, or you can chat your questions, and we'll answer as many as we can for those folks that want to stick around for that. I know it's the end of a Monday on end of a holiday weekend, so thank you so much for spending this time with us.
Yes, thank you all very much. Hope that we answered some of your questions, and would love to answer more if you've got any more questions. Do note also you can go to the 2014nmn.org site and get help there as well. Lots of really good resources on that site.
And I just want to thank Andy and Abby for your excellent presentation. Thank you so much. And for those of you in the Twin Cities area, I'm sorry, but it's snowing, so do drive safely on your way to wherever you are going. We have quite the blizzard out there. So thanks again. Feel free to type a couple of questions into the chat box, and Andy and Abby can field some of those in the next couple of minutes. Thank you.
Okay, yeah, we're not seeing any hands up, so if you have any questions, you can raise your hand or you can chat something in. We are looking at that for the next, well, at least 5 or 10 minutes if you're needing some help.
So there's a question about the software. So this is through the Minnesota Department of Ed. It is go-to training, and then we're just using PowerPoint. And then, Andy, can you talk about the software for the calculator?
The software for the calculator is the TI. Let me see if I can pull this up here. You might be able to see it on my screen. Can you guys see my thing opening up here?
Mm-hmm. Okay.
So right here, the TI tools. This is the TI SmartView TI-30X or TI-34 multi-view emulator. If you look it up on Google or other places, you'll be able to find it. It is for sale. Costs $50 to $70+ probably closer to the 70 plus. You might be able to get it down there around the 50 if you're buying multiple copies for a lab. But when you buy it, you will get the emulator software. It will pop up and it will say, do you want to activate a license or do you want to continue with your trial version? You can download this or ask TI to send it to you and get a 90-day trial of it so you can kind of test it out if you want to try and check it off. Okay, the online resource website, someone just asked, is 2014 NINMN for Minnesota, MN. So 2014nmn.org. That's the site that's being run by Amy Vickers out of Minneapolis to kind of help get some stuff that we have a clearinghouse for people to be able to get in and get some resources. So a really, really, really good website for you to look at.
Clarice, I'm going to unmute you. Can you tell me a little bit more about what kinds of problems you're looking for in terms of practice problems? Or if you don't have a mic, you can. But are you looking for like quadratic written as equations? Are you looking for ones in context? Okay.
Okay. While we're waiting on that, one site that is really good for getting some worksheets and practice with is Kuta Software. It's KUTA software.com. Kuta Software is a for-purchase training program that you can get for pre-algebra, algebra, geometry, pre-calculus, calculus, all that stuff. But within the website, when you go to it, there is a spot in each one of those for free worksheets, and you do not have to pay for the software to be able to use or print the worksheets. And there are some really, really good worksheets on there to help get you some materials you can give to your students for practice.
And Nancy, I see your point. I think you're right. We need to have our students doing problems that are in context. There is a resource that will be in the follow-up material. The acronym is MAP, like MAP. There are these really detailed lesson plans, and there are a couple that deal with quadratics. There's a really nice one that has a sort of extended lesson where students deal with solving quadratics to figure out how to prevent a bus that's turning from cutting into a bike lane. So that's definitely worth checking out. And that site has tons of problems in context, not just ones related to quadratics. That might be another one to check out. And that'll be in the post material. Andy, do you have other resources or anyone else? You can chat them in the box down there related to problems that are in context.
Well, and Dong Tao put in, are there any other websites for GED testing simulator or practice simulators? The GED Ready is available now. We should have gotten links about a month ago that they'll give you a few free copies, but I think those have now expired. But if you go to the GED testing service, look on the GED Ready link, and that is where the official GED practice test will be. I am sure that, and again, I'm kind of making this up, but I'm confident that Steckbon and McGraw-Hill and people like that are going to come out with some sort of practice testing, but it just may not be the official predictor like we have under GED Ready. Type that in. It should be GEDReady.com. But hang on one second. I'm going to look that up. Yeah, McGraw-Hill does have some good stuff out. So as long as you're still looking at my thing here, let's take a look and see if we can just pull this up. GED testing service. Okay, if you go to educators, and for the educators, free practice test. So here's a free practice test off of GED testing service. It's just under /educators free practice test. And here they've got the free practice test versus GED Ready. Yeah, I agree, Amy. I haven't seen it yet either. They did send out a link for requesting free copies or a free code for you to be able to get in and use GED Ready. Notice right here on their page it says GED Ready launches at the end of November. It is past the end of November, and I haven't seen it yet.
I got an email this morning, and so did my colleague, that said that it was ready for us to use.
Oh, great. Okay, I haven't seen mine come through yet, so I'll have to go check my email. But that's a spot where you can go in and check with the GED Ready, and you can, of course, use these sample tests over here.
For the free views, you have to you have to contact GED testing service. We don't have a way to generate them.
Yeah, they generate them. You have to contact GED testing service and request the free codes. They have said that those expire on November 25th was the latest you could ask for a free code, but it doesn't hurt to go in there and ask them again. You know, I can't imagine them saying, no, you as an educator cannot try this. So so here I just clicked on the GED Ready official practice test. And here's options for your center.